This is activity 13, chapter 19, aldehydes and ketones. So we're going to be looking at primary and secondary amines. How do you know if you have a primary or secondary? You're going to look at the nitrogens here. And you're going to look at the carbons directly attached to the nitrogen. In this case, there's 1. In this case, there's 1, 2. Making this a primary, and this one a secondary. Primary amines make amines, and secondary amines make enamines. So the first thing you should do is draw in the lone pairs that are going to be part of the mechanism. So this nitrogen has those lone pairs. Here, this oxygen, this nitrogen. So those are going to be the most important lone pairs that are going to have a role within this mechanism. So nitrogen is nucleophilic, and it's going to attack this carbonyl carbon, pushing these electrons out to the oxygen. So now you will have a negatively charged oxygen and the amine attached, so now you will have a positive charged nitrogen. So you don't want to have a negative charge on the oxygen. So here this is an acid, and we give the electrons up to the base. So now you've neutralized the oxygen, but you still have a positive charge on the nitrogen, so you want to get rid of that. And pushes those up. So now you have everything neutral, but it's still acidic, so this is still going to protonate. So it's going to go to this acid, and there we go. So now you have a positively charged water right here. It's now a good leaving group. So this lone pair on the nitrogen will move here to create a double bond, and this will come off, as you can see right here. But now you have a positive charge on the nitrogen again, so you want to neutralize it again. So right here, this base will get this hydrogen, and this will move down over here to the nitrogen, and this is how you get your amine. So we need to propose a mechanism to make an amine from a primary amine. So again, we're going to start with the lone pair right here on the nitrogen. And same as above, since we're following the mechanism that we did before, the nitrogen is nucleophilic, it's going to attack the carbonyl carbon right here, bringing out these electrons. And then this will give you, so I'm going to draw a phenyl for shorthand. And then right here, we're going to draw in pairs. This is negatively charged. Right here. And this is positively charged. So again, you want to neutralize the oxygen. So what's going to happen is this, and then it gives its electrons to the base. So that is still positively charged. You want to get rid of that. So what you're going to do is same as above. You're going to use that base that was floating around that was left over from the acid. And then that's going to push it up here. So now you have everything neutralized, but this is going to pronate because we're in acidic conditions. So again, we have an acid, and right here we have these lone pairs. And that's going to be positively charged, making it a good leaving group. And then we still have this. So now the lone pair on the nitrogen is going to do this, causing this water to leave. So now you're going to have, the nitrogen is going to have a double bond. And it still has this hydrogen attached, but it's now positively charged. So you want to get rid of that and neutralize it. So you're going to use the base, and that's going to move it this way. And that is how you're going to get your final product. And there's your amine. So now we're going to look at enamine formation. These are made from secondary amines. So again, we're going to draw the lone pair here. We're going to draw these lone pairs. Then this one right here. And those are going to be the important lone pairs for this mechanism. Same as the amine, nitrogen is nucleophilic. It's going to attack the carbonyl carbon, pushing these electrons up. And now you have a negatively charged oxygen and a positively charged nitrogen. So you want to neutralize the oxygen. So here we have an acid. It's going to get that hydrogen, pushing these electrons up to the base. And now you've neutralized the oxygen, but you still have a positively charged nitrogen. So you still have this base lying around. So it's going to get this hydrogen right here, pushing these electrons up to the nitrogen. And now you've neutralized both oxygen and nitrogen. But again, this is acidic conditions. So this is going to protonate. So this lone pair, right here on this hydrogen from this acid, giving those electrons to the base. And now you have a good leaving group with this water. So this lone pair on the nitrogen is going to move here, giving you a double bond, causing this water to leave. So now you have right here the water, but now you have once again a positive nitrogen that you need to neutralize. In order to do that, you don't have a hydrogen directly attached to the nitrogen as in the case of amines. So you need to get the hydrogen from a different location. In this case, it's from the beta. So it's going to get this hydrogen, which is going to then come right here, causing a double bond, but since it breaks the octet rule, those electrons will go up to the nitrogen, which will neutralize the nitrogen, giving you an enamine right here. So we're going to predict a product and propose a mechanism. So we need to make an enamine from a secondary amine. Once again, there's a lone pair on the nitrogen. The nitrogen is nucleophilic. It's going to attack the carbonyl carbon, pushing the electrons up to the oxygen. Once again, I'm going to draw phenol for short. And this is going to be a negatively charged oxygen. This is going to be positively charged. So now you want to get rid of the negative charge on the oxygen once again. So you need an acid, since this is acidic conditions. So this. So the nitrogen is still positively charged, and you want to neutralize that as well. You're going to use a base. Sorry. There we go. And that's going to push it up here. So now you're going to have everything neutralized. But again, this is going to protonate. So you want to draw in your lone pairs. You have your acid. And then this is positively charged. So you're going to have a lone pair here that I didn't draw before, but now it's going to be important, so it's necessary to draw them in. So this is going to be a good leaving group. So this is going to come and form a double bond, kicking water out. But now this is going to be positively charged. So you need to get the hydrogen from somewhere. So we're going to draw that in right here. And you want to neutralize that nitrogen. So you need a base. So that's going to do this. This is going to come here. And this is going to push this up. And this will give you your enamine. And that's your enamine. So tertiary amines are unreactive towards aldehydes and ketones, so there's going to be no reaction. Now, if we look at the structures for A and B comparing to C right here, if you notice, there's no hydrogen on this attached to the nitrogen, so there's no protic hydrogen that the base can attack. So A and B have a protic hydrogen. So this is what will continue the mechanism, versus right here, there's nowhere it can go. So now we're going to propose a mechanism. So if we look, this is acidic, and this nitrogen has a lone pair. So there's only one carbonyl carbon right here, meaning that this nitrogen is going to attack right there, bringing up the electrons to the oxygen. So the nitrogen is going to be positively charged, and then you have right here your oxygen, and that is negatively charged. Once again, you need to neutralize that oxygen. So you're going to use an acid. And then right here, you still have, so now that's neutralized, but you're still going to have this nitrogen positively charged. So again, you need to get rid of that. So you need to neutralize it, and you're going to use a base, and this is the one that's floating around. And that's going to come up here. And you need to draw in your lone pairs for the oxygen, because even though it is all neutralized, that is going to protonate. And now that is positively charged. And the lone pair on the nitrogen right here is going to, so you need to look at which direction the lone pair is going to move towards. The oxygen is more electronegative than the nitrogen, so the lone pair is going to go more towards the oxygen, and the other oxygens are too far. So this is going to move right here, and this is going to move over here, making the water leave. So you have a double bond there now, but now you have the positive charge on the nitrogen. You need to get rid of that. So you're going to use the base. And that's going to move it up here, which is now going to leave you with your product. So this right here is right here. So for these, we're going to predict a major product. So for a quicker way of being able to look at what the product is going to be, if we look at the previous mechanisms for enamines and amines, we have to look at what the nitrogen is attached to, if it's a single bond or a double bond. So in order to first figure that out, we need to look at the nitrogen. How many carbons are attached? Right here we have 1, 2, making it a secondary, and this one only has 1, which is primary. So we know that secondaries make enamines and primaries make amines. So if we look at the previous mechanisms, we'll see that enamines do not have the double bond attached directly to the nitrogen. It's actually on the original carbonyl carbon and the adjacent carbon, versus a primary, so the enamines, is going to have the double bond directly on the nitrogen. So if we think about that, then we can quickly get an answer. So can't forget the methyl group, and then right there. So now we have our enamine, and if we move to the next one, we know we're going to have a double bond directly on the nitrogen, and we can quickly get our answer. So we need to hydrolyze back aldehydes and ketones from amines and enamines. In this case, we're going to be using an enamine. And so the first thing that you want to do is draw in the lone pairs that are going to be important for this mechanism. So right there, this nitrogen, here on the oxygen, on this other nitrogen, and lastly, this oxygen. So the lone pair is going to come down over here from the nitrogen, which is then going to make this get the hydrogen, which is going to then donate the electrons onto the base. So now you have a positively charged nitrogen. You want to get rid of that and neutralize it. So the way that's going to happen is the water is going to attack this carbonyl carbon, pushing the electrons up to the nitrogen. So now you have a neutralized nitrogen, but now you have the water attached, but it's positively charged. So in order to get rid of the positive charge, you are going to deprotonate, and that's going to move it down here. So now you have everything neutralized, but still acidic conditions. So again, there's going to be protonation. But in this case, it's not going to be coming from the oxygen as we have seen before. It's actually going to come from the nitrogen. So here's the goes towards the acid, brings it over here. And now you have a positively charged nitrogen that again you need to neutralize. So in order to neutralize it, you don't want to go after the same hydrogen, because then you're back at the same spot as before, the step before. So you need to look at a different hydrogen, and in this case it's going to be the one attached to the oxygen. And now you have a negatively charged oxygen and a positively charged nitrogen. So what's going to happen is the lone pair from here is going to come here to make the double bond, and this is going to kick this out. And now you're back to a secondary amine. So now you need to make a primary amine from an amine, and you need to have the same intermediate steps. So you're basically doing the reaction backwards in a way. So right here, the nitrogen is going to have a lone pair, and it's going to do this, moving the electrons to the base. So now It's going to be positively charged. So you need to get rid of the positive charge, and you're going to do that with water. So this is going to attack the carbonyl carbon, moving the electrons up. So now the nitrogen is neutralized, but now you have a positively charged oxygen. So again, you want to get rid of that. And you have that base. And it moves the electrons up to the oxygen. So now you have an OH, you have the nitrogen, the methyl, and a hydrogen. So everything's neutralized, but now this is going to protonate, and you need an acid. Oh, sorry, I forgot the positive charge. I know you have a nitrogen, the methyl, a hydrogen, and a hydrogen right there. Oxygen, the hydrogen. And now this is positive. So again, you want to get rid of it. And for that, we're going to use the base. And it's going to go here, and it's going to go here. So now you're going to have a negatively charged oxygen, and you still have a, you still have a positively charged nitrogen, which you still need to neutralize. So right here, it's going to create a double bond, and it's going to kick out this amine. And now you're going to be left with your starting materials, which would create or produce your amine. So we're going to predict the major product for the following reaction. So if we look at the double bond and the location of it, we see that it's not directly attached to the nitrogen, meaning that this is an enamine. And if we think about how the original starting material for an enamine is, we know that the double bond actually moves. So originally, it's going to be over here. With that in mind, we can draw it out, and we know that there's an oxygen right there. So now we're just left with the ring. Now if we draw that out, we have that portion, but there has to be something attached to it to make this reaction possible. So in this case, it's a hydrogen. And this is the major product.